All right, CNT125, Chapter 8, we're on the section on ANDing. ANDing is a logic function. Routers and hosts use ANDing to find out the destination network we're sending to, is it the same network or a different network? So we know if we need to involve the router, if we need to have the router pick this information up and route it to a different network. So this logic function is happening in the router and our devices very quickly. Now, ANDing is a logic function from literally from electronic integrated circuit logic gates, if you will. What actually happens is this: the binary bits are ANDed together, and the logic function is when you have a 1 and a 1, when you AND them together, the result is a 1. Anything else, any other combination, 1 and a 0 makes a 0, 0 and a 1 makes a 0. 0 and 0 is going to make a 0. So I always say think of it like, it's not really, but think of it like multiplication. That's an easy way to get the result. 1 times 1 equals 1. Anything else is going to be a 0. So here's a scenario. Let's say node A wants to send data to node B. Node A, this is its IP address and subnet mask, and here's the B IP address and subnet mask. ANDing is done to verify if they're on the same network or not. If they are, it can send directly. If not, it needs to send it to the router, and the router can forward it on. So node A, here's its IP address and the subnet mask. Now, the subnet mask is written as a SADR notation. The /20 here lets us know there's 20 bits in the network and subnet piece. That's all that means. So let's take the 172.16.32.250. Here it is, 172.16, 31.250. If I write that out in binary, here it is. There is 31.250. The /20 here is the subnet mask written as a bit count. So if we take and write 20 ones, here's 8, there's 8 more, there's 16, 17, 18, 19, 20. Those remaining 4 right there make up the 20. That's what the /20 means. That's what the /20 means. So if I write those out, 20 ones, there's my subnet mask. Now, it actually is going to take this IP and subnet mask and AND them to find out what network does this belong to. This IP address, what network does it belong to? That's what it's trying to find out. So it ANDs them. I'm going to back up a second. A 1 and a 1 makes a 1. Anything else makes a 0. So go back to my example here. 1 and 1 makes 1. 0 and 1 makes 0. 1 and 1 makes 1. 0 and 1 makes 0. 1 and 1 makes 1. 1 and 1 makes 1. 0 and 1 makes 0. 0 and 1 makes 0. Well, it's very quick to see whatever this number was here, and it with 255 is going to yield the same number. Nothing changed. So I have 16 here, and it with 255 is going to yield 16. Again, nothing changed. It's when we have an octet where we have a number with a subnet mask where ANDing has, where subnetting has occurred. When I have a subnet mask where subnetting has occurred, it might change. It's most likely going to change. So we definitely need to, as you see here, I have it highlighted orange, we definitely need to AND this octet. 0 and 1 makes 0. 0 and 1 makes 0. 0 and 1 makes 0. 1 and 1 makes 1. And the rest here are going to be ANDed with 0, so they're going to be zeros. So literally 1 bit fell through. Just 1 bit fell through. That, when I write it out in decimal, is 16. So what that tells me so far is this address 31 belongs to the 16 subnet or 16 network. That's what that's telling me. The 250 over here, here's 250, ANDed with all zeros is going to yield 0. So the host portion, what's actually happening is the host portion over here, all these remaining pieces out here, these 4 bits here and these out here, all those literally turn the host portion to 0. That's what the ANDing's doing. The ANDing literally just drops off the host portion, so it comes through as zeros, and the only thing that's left is the network and subnet piece. But it's represented as the network number. So 172.16.31.250, that node IP, that IP address of that node, when ANDed with a subnet mask, yields the network or subnet number. In this case, 172.16.16.0. So this node A is part of the 172.16.16.0 network. Let's look at node B. Here's node B. And this guy. Again, I don't really need to AND the 172 and 16, but I do need to AND the 32. 32 ANDed with this 240 is what it is. 1111 is going to yield 32. And the host portion out here gets dropped down to 0. So this node belongs to the 32, 172.16.32.0 network. So when I now compare them, node A is part of the 16.0 network. Node B is the 32.0 network. Oh, they're part of two different networks now. They might be on two separate floors and two separate buildings. Could even be two separate campuses. But they belong on separate networks. So when A wants to send to B, A is going to have to send it to the router, and the router will do this and look up and go, oh, what the 32.0 network, I know where that is, and it'll pass that out the appropriate port to get to that network. That's what ANDing does. Now, the book shows us this for two reasons. One, this is actually kind of helpful to find out what subnet or network something belongs to. I have actually used it to find out, a printer or something, what network is this belonging to, that sort of thing. This is also handy to realize this is what routers do, but I do kind of put that in the category of, I'm putting air quotes around it. That's nice. That's nice what routers do. It gets us an idea of what the routers are doing. It is also helpful sometimes with troubleshooting a network, like I said, a printer belongs to or device belongs to. And it's also helpful when you're doing certification exams. You can quickly, in this case, I could kind of ignore these octets. I could kind of ignore this one, and I could quick AND this and to find out, oh, this thing belongs to the 32.0 network. And that might allow me to answer a question on a certification exam kind of quickly. I could potentially do that. So it's a little trick to use for various reasons. But there is your ANDing function. There's your ANDing function when we deal with subnets. And again, this is what routers are doing at the blink of an eye, snap of a finger. They're doing this to go, oh, this belongs to this network. It looks it up its routing table and passes out the appropriate port. Next one, boom, belongs to this network. Looking up at the routing table, pass out the appropriate port to move it on its way. That's what your routers are doing.